navigation by the stars in 3 communities around the world. On Rode Island in Fiji in the South Pacific, the Kirkin Islands in Tunisia, North Africa, and on Chesapeake Bay at the United States Naval Academy. I purposely chose those 3 communities to juxtapose fishermen with naval officers, but they all did navigation on the ocean, and that's what made them connected. How do you get home if you're on the ocean at night when there's a flat water and all you can see is the stars? And that's what I pondered, and that's how I learned how they each use the stars in their communities to navigate at night.
In the Northern Hemisphere, most people use the star Polaris for navigation because it's the star that's closest to the North Celestial Pole. And over the course of a night, it appears to be stationary. It doesn't move. You've heard lots of stories about following the North Star. They really do it. The navigators really do it because it's really easy to use for night navigation. As you move south from the North Celestial Pole, it disappears the further south you go, or it lies down on the horizon, so it can't be used for navigation at night. Thus, in the tropics, they use the stars in a different way. In the tropics, the stars move differently. Almost the entire sky rises in the east and sets in the west. So you have to have a navigation system that makes use of those rising and setting stars, which is what they do on Rode Island in Fiji in the South Pacific. Here we are at the Royal Observatory, Edinburgh, in Edinburgh, Scotland, on the top of Blackbird Hill. Astronomy presents another set of puzzles. There's facilities like this one, observatories set on relatively high hilltops, which gave you less atmosphere to look through in order to see the clouds, see the stars, without as much twinkle and without much interference in the upper atmosphere. So it used to be that astronomers would have to trek to the top of hills to do their observations, but nowadays they've automated the telescopes so that you can sit in the comfort of your own home or your own office, and you can direct somebody else who's taking the data for you. So this is a huge shift in the way that astronomy was done 50 years ago to the way that astronomy is done now. Ivana asked me what's been lost now that astronomers don't have to go to the top of hilltops to collect their data at observatories, at telescopes. Now there's somebody who's altitude adjusted, who pretty much it's their job to collect the data for you. And the data is then packaged and emailed to you, or in a Dropbox where you just pick it up the next morning. So you don't have to travel, you don't have to suffer high altitude, and you don't have to stay up all night, which is what astronomers used to do. So Ivana asked me what's been lost now that astronomers don't have to go to observatories. And there's a lot of negatives that have been removed because, of course, observatories are lonely places, dark places, and given all the sexual harassment issues that have come to the fore, they could have been dangerous places for women to go observing, where you're with, one or two male scientists all night, and then sleep all day, and then all night again. So it's a little bit less dangerous that way. You don't have to suffer altitude sickness. But there is a little bit of a disconnect between ownership of that data. Of course, astronomers still feel like they own that data, but there's a difference between taking it yourself and seeing if the integration time is long enough. Do you actually see the object that you are trying to see in the field of view? Can you change things on the fly, which used to be able to happen when you were observing at the telescope with the telescope operator. Now you have to have everything set perfectly in advance, and you don't even have to be awake while they're taking your data. So something has been lost, but it really, the whole field has shifted. It's not just that they don't go observing, it's that now we have so much data that you have to be cognizant of how to program in Python or Fortran or IDL in order to handle all the data that's available to you now as an astronomer. So the trade-off is we no longer go up to telescopes, but we now have so much more data in which to ask our scientific questions and get our scientific answers. So there's a trade-off, right? And there's a bit of poetry, and I think that Ivana really wanted to get to the poetic aspects of going up to observatories. It's dark, the skies are beautiful, it's just you and the sky, and it's cold, and it's a transformative experience in some ways that no longer gets experienced by every astronomer. So there's that poetic aspect. Ivana's animated sphere is amazing because at points it emulates what it looks like to have a gravitational lens out in space. That's when a big galaxy between us and a bunch of other galaxies distorts the light of the galaxies behind it. It's absolutely beautiful. So Ivana has this wonderful art piece called Planetary Nebula, and immediately when I saw that, I'm like, I have to make some comments on it. First of all, for two of my major projects, I studied planetary nebula. When I was an undergraduate, I was looking at a planetary nebula in near infrared a bit, and I was looking for signatures of dust. So planetary nebula are these great things because they have a story about how it's misnamed. When the first people saw them, they were round, they were a bit of an extended object, and the color was greenish. So they actually thought that they were planets. But then they figured out over time that they were, in fact, the dying shells coming off of a dying white dwarf star, so the outer atmosphere of stars as they convert to being white dwarfs. And they couldn't identify what that green element was because they had never seen it on Earth. And in fact, it's just oxygen, but it's a forbidden state of oxygen that you only see under very, 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 very low density conditions. So basically you only see it in space, and that's when oxygen will glow green if it's present. So when I was studying planetary nebula, they're just the normal shaped ones, you know, spherical ones, I was looking for if they had cooled enough to form little clumps of what we would call dust. So that was my first planetary nebula project, and my second one was for my master's thesis, and that one I had a very complex planetary nebula called the Eskimo Nebula, and it had clumps and it didn't make sense, and we wanted to model it as a sphere, but clearly it had more structure than just a sphere. So part of my job was modeling that planetary nebula. Now in Ivana's piece, it's pretty much a ball. Right. It is a beautiful ball, but it has both the characteristic of being a solid and being able to see through it. And this pretty much describes what a nebula is like. The color makes a barrier that makes it look whole, but you can see through it, so you know that it's a gas. And I think that's what she was going for with that particular art piece. And I really thought it was well done, and I quite liked it.